All right, so this problem is very similar to exercise 6. So if you've already watched the video on exercise 6, this will be even easier for you in some senses, but it does have a bit of a twist to it that exercise 6 did not have. Each of the problems begins as an improper fraction, a fraction that represents more than a whole. And our goal is to express it as a mixed number by using division, and then we'll check by inverse. The diamond gives you the answer in the last slide for this particular lesson, which is week 1. So if you're watching this video later on, this will only help with week 1. But the sun is what we're going to use for our example right now. And so that is 67 over 4. Now, our goal is to figure out how many wholes there are in here and what's left over. So I'm going to divide this by a whole fraction. Well, what would a whole fraction look like? A whole fraction would be something broken into pieces, and this says break the pieces into 4s. And a whole would be all of that filled in. So filling this, 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 and this. That's a whole. So in our problem, a whole is represented by the fraction 4/4. So the denominator, but replicated or copied on the numerator. So our goal is to figure out how many 4/4 there are in 67/4. If you divide fractions, you can divide straight across if it works. So 4 divided by 4 is 1, and 67 divided by 4 is going to be a mixed number that we'll find now. So I do know my 4s, but I'm going to list them out anyway. 4, 8, 12, 16, 20, 24, 28, 32, 36. You only need 9 of them to be able to do long division. 4 goes into 6 one time. That makes 4. It's this one. Take away, you get 2 left over, which is smaller, so that's good. We can bring down the next place value, 7. 4 goes into 27 here. That's the closest I can get. I can't go over, so it has to be the 24, which is 1, 2, 3, 4, 5, 6. 6 times 4 is 24. Take away, we have 3 left over. And what that means is that you have 16 of these, 16 of those, and then you have an extra that has 4 parts, but you only have 1, 2, 3 of them shaded in. And so this tells us that we have 16 wholes and 3 out of 4 left. 3 out of 4. So our answer is 16 and 3/4 over 1, but if you have something over 1, then you can divide it by 1 and it's itself. So 16 and 3/4. In the box, what you want to do is put 16, put a space, and then 3/4. And I'll make sure that the box is big enough so you can show that. This is our answer. And now we're going to check by inverse. Inverse of division is multiplication. And so I have 16 of these. So I'm going to multiply 16 times the whole fraction 4/4 because I have 16 of them. 4 times 16 is 4 times 8 and 4 times 8 again. So here's 8. If I double that, that's 64. And then when you multiply by a whole, the whole can be expressed as over 1. This is over 4. Well, that does not look like our original fraction, but it's super close. 64/4 is really close to 67/4. I'm just missing something. Oh, I'm missing the extra. So I'm going to take my whole fraction and add the extra 3/4 to it. And that's equal to 67/4, which checks out. That is equal. So this mixed number is equivalent to this improper fraction. So this is the answer, and this is the checking method. You can take a picture of that and put it into your work here if this is your problem. If it's not, hopefully this helps you with the process for how to do your own, which is either this problem or another one in a future week.